Hello and welcome to the Climate Resilience Podcast, brought to you by JBA Consulting. I'm Phil.Emonson, and in this podcast series, we unpick some of the complexities, challenges and opportunities on the topic of climate resilience with some inspirational thought leaders. Whether you're working on local adaptation projects, planning for climate risk, or simply looking for hope backed by science, you're in the right place. If you enjoy these conversations, be sure to follow the podcast and subscribe wherever you listen. Share with your friends and colleagues too, anyone interested in building a more resilient future. Now, let's jump into today's episode. We'll start today's episode with a question. What do soils, climate resilience, food, human health, and a rock star have in common? Well, the answer is my guest today, Professor Jack Gilbert, who is a global expert on soils and soil health. We're going to be chatting about why resilient landscapes start underground. And if you think that soils might sound a bit dull, well, trust me, we're going to change your mind because we're going to have a great conversation. Jack, I'm delighted that you've come on the podcast. It's great to have you. So welcome. And maybe you could start by giving a short introduction to yourself and your career background.
Sure. I'm Jack Gilbert. As you said, I'm a professor of pediatrics and oceanography at the University of California, San Diego, which obviously makes no sense with regards to soil health. But my background is in microbiology, and microbes are everywhere. You know, you have 40 trillion of them in your body. In a gram of soil, there's over 1 billion cells. Every teaspoon of seawater has 1 million cells. So we're talking about an enormous, expansive microbial world. Really, this is just a microbial planet that we've come along to colonize in the last few million years. And they colonized us and they use us to their whims. So as a microbiologist, I can study everything. In fact, I think I'm the world's first pediatric oceanographer or oceanographic pediatrician. I'm not entirely sure what I am, but microbes are my friends and the things I study.
Brilliant. Good stuff. Well, as I said, absolutely delighted to have you on the podcast. And we've got a lot that we want to talk about. So, look, I'm going to take you back maybe 25 odd years to the early 2000s. I was an undergraduate doing a geography degree, and I did a module on soils. So I did that student thing where you pop off down to the local bookshop, pay your £25 or whatever it is to get the course textbook. And if I'm honest, the first line disappointed me somewhat because it said that, and I quote from my memory, soils are the stuff in which plants grow. So quite a low bar that I'm hoping we can expand on and elaborate on today. Now, look, if I was to define what a resilient landscape is, I would probably say that it's a dynamic system, a diverse system that can adapt over time and maintains human health and also ecological integrity. But I think that perspective is shaped by the above ground lens. So, Jack, let's ease into this gently, right? What does climate resilience look like below the surface?
Yeah, I mean, you actually captured it pretty well, right? Above as it is below. In this context, I like to think of the soil like a giant sponge. It's one of the most visually compelling things I can think of. The microbial world that lives in the soils. These are all the fungi, the bacteria, the viruses, and even the little protists that run around inside there. They play a foundational role in managing how water moves through soil. If you've got a rich, diverse rainforest of microbial organisms in that soil will hold a lot of water. It will maintain water content. And if you don't, it will just flood through like it's sand, right? And so understanding resiliency is all about understanding water dynamics and understanding the movement of water through a system. If you can keep water present in soil, your crops will have more water when they need it, but they'll also have less water when they don't, because that soil hydrology will be functional. It will make sure that the plants have what they need. So a resilient soil system is one that can maintain water content at an appropriate level, and also manage the nutrients and the richness of the soil to manage growth and opportunity when things run out, right? When there's not enough of
Mm,
the nutrients or the water available.
mm, mm. And so when we think about a changing climate, then our soils will be increasingly exposed to um, seasonal waterlogging, extreme heat, extreme wildfires linked to that. So I suppose, how does a soil maintain and sustain its resilience to these increasing stresses that we're seeing?
Yeah, and a lot of that is just let nature take its course, and we've kind of
Uh-huh.
ignored that over the last few hundred years. The Industrial Revolution saw the introduction of herbicides and pesticides and chemical fertilizers, chemistry, which really was the science of the 19th century. Physics being the science of the 20th century, and biology now finally getting its heyday as the science of the 21st century.
Mhm.
But chemistry provided us with an opportunity to massively increase the yields that our soil systems could produce so we could feed the world. But the problem with doing that is we overburdened those soils with chemicals, nitrogenous fertilizers, phosphates, potassiums, and we added in a load of compounds which killed off the weeds and killed off the insects, and we ended up with a soil system which was pretty monocultural. Not in terms of what goes on above ground, but what goes on below ground. We selected for a microbial monoculture in the soil, and that meant that the soil wasn't particularly resilient. It didn't have the
Mm.
diversity of microbial life to adjust and adapt when things went wrong. So, what we talk about when we talk about resilient soil is one that has a living, dynamic microbial world living inside it, and some little macrobes like worms and plants and buffalo or whatever you want to call them. But those the microbes are the most important, and those microbes they make the soil more porous. They make the soil more spongy, so it can suck up water. They also cycle all those nutrients and keep the nutrient system functioning properly. So you've got enough nutrients going to the plants. So you've got this ecosystem of services which we don't have to provide, but that can help to fuel those systems to produce adequate crops and systems which enable us to feed the world effectively.
Yeah, yeah. And without wishing to jump the gun to a conversation that we'll have later in the episode, how do we get that diversity, that variety?
Yeah, there's multiple. This is interesting.
Yeah.
I mean, there's multiple ways of getting to that end, right? There's
Uh-huh.
multiple ways to be sure we can produce a healthy soil, a healthy agricultural system. And we've
Mm,
seen this. We've known this for years. Cover crops,
mm,
the rotation systems, ensuring we have diverse cropping systems. So like row crops that are now allow us to have different plants growing in different parts of the soil system.
mm,
Making sure that we are effectively managing fertilizer inputs with potentially organic fertilizers,
mm,
using different kind of cropping, animal grazing strategies to allow for the manure and the animals to support the growth of those systems. There are many different ways of doing it. We have recently started to develop and adapt ways of using microbes as almost like soil
uh-huh.
probiotics or crop probiotics, living bugs that we can add back into the soil to help them regenerate faster and help those systems to become more stable more quickly.
Brilliant, brilliant. Um, you touched, I think, very briefly on in at the start about the role that soil plays for human health. So I want to turn attentions to that. So from soil health to human health, if you will. um it's continuing the thread a little bit. Why is it important then that we reverse soil degradation, but particularly when it comes to human health? And as a follow-up question, and I've got a vested interest in this as a father of two young boys. But I was in a talk you gave a couple of months ago when you set out a very clear link between um, childhood interaction with nutrient-rich soil and, I think I'm right in saying, increased learning capacity or potential in the classroom, and that completely blew my mind. So two questions in one there, but maybe you could pick those up and we could take that forward as a thread.
Yeah, we as a species grew up in the microbial world, right? Our
Yeah.
species is approximately 100,000 to maybe 1 million years old. We have an ape lineage going back about 5 million years. Our mammalian lineage is maybe 250, 260 million years old. It's not particularly long, right? Microbes have been on this planet for 4 billion years. So
Mm,
we're talking about a novel innovation. So our species and our body plan grew up in a world where we're constantly exposed to microbes. And our immune system really developed less as an army ready to like kill all the bad bugs and bad things that come into contact with us, but much more like a gardener or a farmer. It's there to manage the microbial exposures that we have every day, every minute, and to
mm,
use or cultivate those microbes that provide benefits to supporting our body. So our body evolved in a world where it's surrounded by life, and it's now using that life through our immune system to support its health and processes. When
mm,
you take somebody and you isolate them from those sources, from those microbes, from that life, their body will not function as it was evolved to do, right? As we were
mm,
selected to
mm,
function. And so, for years now, we've been exploring whether children, especially because their immune systems and their bodies are developing and growing, especially in early life, whether children are who are living in urban environments, who are subject to extensive hyper cleanliness standards. There's a difference between hygiene, by the way, and cleanliness. But anyway, hygiene is just a health promoting environment, and that could be many things. But there's some of these kids are being totally removed from nature.
mm,
And what we saw is that that leads to an increase in allergies. It leads to an increase in physiological differences in their bodies. It can lead to an increase in neurological differences in their bodies. And some of these situations potentially can lead to deficits in those
mm,
properties. So kids can grow up with reductions in neurological and physiological outcomes, which may not be beneficial for them or preferable for them.
mm,
So, what we've
mm,
actually found is that when kids are reintroduced to some of these biological phenomena, like a healthy soil or a healthy environment, it can actually help their bodies to develop and grow effectively so that they can improve upon or maybe get back to the physiological and neurological state that they had prior, or we had as a species prior to that isolation mechanism. Um, you know, I, I could riff on this for ages because it gets
feel,
really exciting.
feel free, because as I say, it genuinely blew my mind. This scientifically proven link between, as I say, interaction with soils that you've been talking about, and then learning potential in the classroom. So look, I'm fortunate. I live out in the country. We have an allotment, and just this last weekend, we opened up the hatch at the bottom of the compost bin and took out some really dark, beautiful compost, and my boys were there, and it was wonderful. And I was explaining the process, because actually, if you lift the lid off, of course, at the top, you've got potato peelings and apple cores and grass cuttings and all that stuff. So actually, that process was wonderful to see, in their eyes, but also it was just a lovely experience to be able to touch and feel that really dark, rich soil and compost, and spread it out. But go back to that link then, that scientific link, which um, i- which improves classroom learning capacity. Is it the capacity for learning? Was that the?
Yeah.
Yeah, yeah.
Well, capacity or potential. I mean, so a child that grows up in we started this research almost 15 years ago, working with two groups of agricultural communities in the US called the Amish and the Hutterites. And the Amish, a lot of people are aware of, right? They
mm,
don't really like technology,
mm,
and they live on family farms and they drive buggies and horses, and they, don't like engines and electronics.
mm,
And so we found a unique disparity between the Amish and the Hutterites. Both of them live in these kind of technologically depauperate environments, right? No iPads, no iPhones, no cars.
yeah.
But they have two different ways of farming their land. The Amish live on family farms, right? The kids
Mhm,
grow up
mhm,
working on the farm. The front door is 50 feet from the barn door, right? It's a working environment, and the kids are very, very much part of it.
yeah.
The Hutterites, their families are actually living in housing communes, which are distant from the farm, and only boys over the age of 14 years old are allowed on the farm. Right? They've
Okay.
got a very strict policy.
Yeah.
Now, these people all come from Central Europe, Northern Europe, right, originally, and they have very, very similar genetic predispositions towards the development of allergic disease, things like asthma, right?
Mm,
And we found, though, that they were very discordant for asthma. What does that mean? The Amish had maybe 4% of their population developing asthma. The average for the US is like 8 or 9%,
mhm,
right? So
mhm,
it's significant reduction in the likelihood of developing asthma. But the people living in Hutterite communities had almost 25 to 30% asthma, and a significant increase in neurodevelopmental conditions. And their school readiness scores were lower than the Amish, right? And what do I mean by
ah,
school readiness? That means that a kid can come into kindergarten or first grade here in the US,
mm,
and be ready and be able to participate in the classroom. And so we thought this was fascinating, right? It turned out we could take dust from Amish children's bedrooms, which very much look like farmyard dust, right?
yeah,
Makes sense
yeah,
if they're working there and
yeah,
they're going to sleep in that room and breathing all that dust in deeply into their bodies. That you take that dust and give it to an animal, and it would alleviate any allergic disease in the animal. I'm hyperbolically stipulating that, but that's what the evidence
mm,
pointed to.
mm,
And subsequently, we've taken children and randomized them to receive healthy soil exposure when they're in kindergarten or preschool.
wow,
And it's remarkable when you take these kids and you randomize them, say, look, hey, here's a big tub of healthy soil, and here's a tub of soil from an urban environment. And we're going to
mm,
randomize you kids go and play in this tub of healthy soil from this forest. You kids go and play in this tub of soil from an urban parking lot, and we'll see what happens. The kids that interact with the soil from the forest, the healthy, rich, diverse soil, have lower levels of inflammation, and they tend to have much more be much more ready intellectually for school when they go to school at kindergarten
yeah,
at the age of 5. And we've currently got a study ongoing up in Washington where we're literally taking kids and randomizing them to either receive an outdoor education in a forest environment
ah,
or an indoor education in Seattle in an indoor preschool. And in our preliminary data, we're seeing a very similar trend. Kids have lower levels of inflammation and are more ready for kindergarten
mm,
when they have that outdoor education. So all this points to the fact that when you, as a child, are exposed to a rich, diverse microbial ecosystem in that soil, a rich, diverse soil with lots of immune stimulation, you're much more likely to develop immunologically and physiologically and neurologically, as our ancestors would have expected us to develop.
yeah,
And therefore, our bodies are more standard, right?
yeah,
Less depauperate.
yeah,
And this to me is an indication that we can potentially package this healthy soil environment up and give it to people as a way of helping their bodies to develop to the fullness of opportunity.
yeah. I mean, it's just it's phenomenal stuff and great scientific research. But as I say, it absolutely just blew me away when I heard that for the first time. Um, there's an interesting thing that you've just been talking about there with the example of those two cultures. Um, which I'd like to sort of dive into a little bit more. And it's about the link between soils and a sense of place in many respects. So, as we said, living, dynamic, resilient landscapes rely on healthy soils, but I think there's a lot more to it, actually, particularly in respect of culture, identity, local knowledge. So, why is it that soils were historically culturally important, and how can we perhaps use some of that to inform land stewardship, land management now, particularly given all those stresses that we've spoken about, particularly climate change, but increased sort of fertilizer and pesticide use, etc.
Yeah, one of my favorite authors, Philip Marsden, who's also I think he lives in Cornwall in the UK. He's a wonderful author, and he talks about place and what it means to be in a place. And I've been an immigrant now for most of my life. I've lived outside of the UK much longer than I've lived inside the UK, where I was born. And it's quite remarkable how much you miss aspects of your home environment, not just you know chocolate and hot cross buns, although I do have on for both, but the environment which you grew up in,
Yeah,
right?
yeah.
And this is an interesting ancestral identity, right? It's not
Mhm.
we think of place as being extremely important because it grounds us, and we use that language, the grounding of
Yeah.
us, right? Our ability to be grounded in an environment, and that's very linked to the soil, right? Obviously,
Mm,
by
mm,
biological ideology and also reality.
mm.
And there's interesting historical perception to this. The Chinese living in ancient empire-based China used to take a pot of soil from their hometown when they were sent to the peripheries of the empire to administer different regions, because they believed that when they were feeling sad or got sick, GI issues or just mental health issues, that taking some of that soil and making it into a tea and drinking it would make them feel better. you
Right.
know, the world is a strange place, right? And
Mm.
they also, ancient peoples used to think many things which may not be reality today. But these same people also develop strategies of taking something wonderful called a yellow soup, where they take a bowl of infant, pure child's feces and leave them with a piece of cheesecloth over the top outside overnight to ferment, and then make someone who has persistent diarrhea drink it in order to make themselves feel better,
Oh,
which sounds crazy,
yeah.
but turns out to be one of the first recorded evidences of a fecal microbiome transplant, which has become our primary and most effective strategy for treating recurrent Clostridioides difficile infections
Oh, okay.
in our human populations today. And it's one of the only FDA approved microbiome therapies in the world.
God.
So they may be onto something. So the idea that you could take dirt or soil from your home community and use it to stimulate your immune system, rebalance, therefore, your neurological inflammation and your
Ah,
physiological homeostasis may have extraordinary merit, right?
right.
And that idea that it grounds us to have a home where our childhood physiology developed, I find absolutely fascinating.
Isn't it just?
It may be highly nuanced, but I think there's a big opportunity there to explore ways of using the microbiome in our home environments to help us live a healthier, more profound life.
Yeah, yeah. So I now live in the southwest of England, but I'm originally from Telford, and I think it's safe to say nobody's ever made tea with soil from Telford when they've been feeling low or under the weather. But maybe I'll give it a go.
Well, they've never
I've
tried.
never tried.
They've never
Maybe I
tried, Phil.
should. Exactly.
Yeah.
Nip back to Telford and take some soil with me next time I go. Um, this is just phenomenally fascinating stuff. Um, One of the introductions I gave was to a rock star. And so that is because the first interaction I had with you was at the Anthropy gathering at the Eden Project earlier in the year. And for listeners, if you've not listened to the episode from December of 2025, when I had a conversation with John O'Brien, who's the founder of Anthropy, then I'd recommend that you go back and listen to that. But the Anthropy gathering was superb, and you shared a stage with the Edge from U2 talking about soils. Now that sounds incredibly impossible, but it is because it's framed around a Soil Stars initiative. So tell me what Soil Stars is all about, Jack.
The Soil Stars is a think tank, if you will, of independent scientists that is run by a British charity, a scientific society called Applied Microbiology International, which is actually one of the oldest microbiology societies in the world. But this microbiological societies are like all kind of scientific societies. It's just a group of geeks that get together and talk about things. So we developed the Soil Stars because we found a group of people who were extraordinarily passionate about trying to save our soils. Our soils are degrading around the world. They are being wiped out by industrial agriculture. Changes in climate are causing significant erosion of our soils. We're losing millions of tons of topsoil every month across the world, and it's significantly damaging our ability to maintain agricultural productivity, let alone the environmental and ecological toll that it's putting upon our planet. So we are in a urgent situation where we need to develop and design techniques and strategies and actually employ those strategies, do
Yeah,
something, not just talk about it, to facilitate backstopping our ability to maintain soil health around the planet and potentially to reverse the decline in our soils to make sure that in
mm,
100 years
mm,
we have highly functional, highly stable soil systems, and to
mm.
put the passion back in the soil. And if you want passion, go and speak to musicians, right?
Yeah,
The Edge, who I think his fellow bandmates call him Professor as a joke, but also because he is one of the more intellectually rigorous ones in the band, I'm sure,
mm, mm,
as the lead guitarist. But he is an incredible intellect when it comes to identifying and strategizing ways of solving problems. And he really has bent that intellect towards soil health. It's become a passion of his. So,
yeah,
I was introduced to him 2 years ago, and I immediately saw the opportunity to integrate him into a think tank that would facilitate us leveraging his passion and his energy and, to be honest, his
yeah,
convening power to
yeah, yeah,
facilitate us building a narrative, global narrative around soil health. And along with my
yeah,
colleagues, Janet Jansen, and lots of other scientists, and now musicians and leaders in soil health, such as Sir Tim Smith, who
yes, yeah,
founded the Eden Project and the Lost Gardens of Heligan. We are building a community of thought leaders to help us put the science into practice, the ideas into rigorous application, so that we can actually move the needle in terms of supporting regeneration of our soils and maintenance of soil health.
and that is fantastic, and actually neatly brings me on to what will probably be our last conversation topic, and that is particularly about how we turn your years of scientific rigor into, as you say, climate action, something that will improve soil health, soil resilience around the world. And this is where Oath Biome comes in. So I know this is something you're hugely passionate about. So tell us what Oath Biome is, what it's all about.
Yeah, so Oath Biome is or Oath Life, or Oath Soil Health, whatever you want to call it.
Mm,
It's actually a public benefit corporation. It's a corporation that was put together by a group of um, uh, uh, scientists, musicians. The U2 is one of their main backers, alongside other leading lights in Hollywood and beyond, and some impact investors in the VC community who really wanted to put together a company that actually wanted to make a difference. not just make money, but make a difference in the world. This is the only company I've ever been involved with as an independent scientist where science has been first. Many companies come and say, oh, "I've got a product. Can you be a consultant? Put your name to this," and they just want your name. They want to use your reputation. Say, "Look, I've got serious scientists on board." This
Yeah.
company, and maybe this is because Edge is one of their co-founders. This company has come at it from a completely different perspective. They said to the scientific community, "You tell us what's the best strategy here. What should we be doing to address this critical problem in the world?" And then not just the scientists, right, but the farmers, the people actually doing the growing, the people getting up at 5 o'clock in the morning and maintaining these farming environments. They've actually brought on board the entire farming community, government operations, scientists around the world, and said, "Hey, we want to make a difference. How do we do that now?" And so this is let's say, public benefit corporation. I do have stocks and shares in that company. I do have a conflict of interest with them, but I honestly believe it's a force for good in terms of trying to
Mm.
change the world now with practices that will have real impact. And the strategy that Oath has been going after is focused on microbial technologies, which is obviously very big passion of mine, being a
Yeah, yeah, yeah.
microbiologist. I think we can use microbiology to solve some of the world's biggest problems. And one of the world's biggest problems is soil health and the degradation of our soils. So Oath has taken that on board, taken on board the scientific direction of the entire community, well, a significant proportion of them, and has said, okay, let's explore this. And they're developing microbial technologies to replace synthetic fertilizers, to improve water holding capacity, to replace or reduce the need for things like herbicides and pesticides, so that in addition to other regenerative practices like no-till, like cover crops,
Mm.
you can have another technological solution embedded in your practice to help to accelerate soil restoration and make soils more resilient for future dynamics. And so, hey, we have an urgent problem here, right?
Yeah,
And we
yeah.
need urgent solutions. And it's time for us as scientists to back solutions that we think have real merit. And that's why I put my name and reputation behind an
Yeah.
organization which is trying to achieve that.
Ah, it's so refreshing, and I can hear the passion in your voice. And you're right. We're faced with a climate emergency, and we have to take action. So, really wonderful to hear everything you're doing to improve resilience of soils. I said that was probably going to be the last sort of conversation topic. I would like to close though with something a little more profound, perhaps. So. Um, Jack, if we get soils right, what what changes? Not just environmentally, but culturally and socially. What changes?
One of my very good friends and mentors, Joe Handelsman, who was the scientific advisor to the Obama administration, led the
Yeah.
Office for Science, Technology, and Policy, and is one of the world's most eminent microbiologists and soil scientists. Says it best. She goes, we start with the soil. Our bodies are, in every religious culture on Earth, we come from the soil.
Yeah.
And our entire lives are dependent upon the soil. Outside of
Yeah.
agriculture is incredibly important to us. So it's while improving soil health, soil resiliency, making soils more spongy, making sure they can suck up more water, making sure they can be more resilient in terms of nutrient density is important, and it will help reduce pollution in rivers and in oceans. It will help
Mm,
mitigate climate change by drawing down carbon. It will help with so many different practices. It will make agriculture cheaper, right? The key thing that we need to achieve is making soils the center of our society and our social structures. We want people to understand to ground themselves in the soils in their community. To do essentially what you're doing, Phil, with your kids, like let's get out there.
Mm,
Let's
mm,
start understanding where our food comes from. Let's work with our
mm.
farming community to hold them up as leaders, as social cultural heroes for our
Yeah,
community.
yeah,
They
yeah,
are the stewards of our soil. We need the governments of the world, and I, speak to you as a person living in the United Kingdom, and the government of the United Kingdom to support our growers and our farmers, and help them to engage with the latest in soil science, so that it's part of our social cultural reality. It's a part of our social cultural identity that soils are at the center of our society and community. If we can achieve that, we can save the world.
And there it is. There is the passionate and scientifically informed call to arms. Jack, that's been an enormous amount of fun. I've learned an awful lot, and I can only thank you for bringing your valuable and wonderful insights to this episode of the podcast. So, Professor Jack Gilbert, thanks for coming on the podcast.
Thank you so much. Lovely to be here.
So we've reached the end of our time today. If you've enjoyed listening, please hit the subscribe button so you're ready for our next episode in a month's time. And if you'd like to support the show, consider sharing it with others or leaving us a short review wherever you're listening. It really helps more people to discover and enjoy the podcast. Thanks for joining us. I'm Phil Emonson, and you've been listening to the Climate Resilience Podcast, brought to you by JBA Consulting.
If we can achieve that, we can save the world.